everyone, we're going to find the value of the constant a such that 4 to the power of a equals this expression given. This would be considered a hard problem because we have these double radicals here. So what we're going to use is these two formulas here to help us simplify this. Anytime you have this double radical, we want to look at this a plus b squared, because when you have the square root of that, you just get a plus b. And that's what we want to do. For our 2ab, we're going to use the square root part. So we basically need a 2, and then we have square root of 3 times 1. And that's what you look at first. So we're going to rewrite our radical. And I'm just going to do this first one because this one's the same except it has a negative. But we can write this as the square root of 4 plus 2 square root of 3 divided by 2. It's exactly the same thing because all I have to do is divide each piece by 2 and I get back to what we have. And again, this is our goal. So we wanted to get it just to look like some a plus b. Now, to do that, what you're going to do is write this as we want a 3 times 1. So we're going to write the 4 as 4, not 4, but 3 plus 1. Because 3 plus 1 is 4. And then we're going to have plus 2 square root of 3 times 1. Let me put that under red like that. All right, all divided by 2. Now, let's rearrange this. I'm going to put the 3 first and write this. My 3 can be written as square root of 3 squared. Right, because that equals 3. Then I'm going to put my plus 2ab. And then my b is going to be 1. So that's going to be plus square root of 1 squared. And then our denominator, we're just going to separate that out and put square root of 2. Now I can write this as square root of 3 plus square root of 1 squared. I'm writing it like this. All right, all divided by square root of 2. And this is just going to give me a plus b, which is square root of 3. Square root of 1 is just 1, divided by square root of 2. So just looking at this inner function here, this inner expression, we're going to get square root of 3 plus 1 divided by square root of 2. Now this one's the same thing, but we have minus. So that's just going to, we have a minus here, so put minus. And we're going to get the same thing. It's just going to be square root of 3 minus 1 divided by square root of 2. Now this is going to equal, let's see, when you simplify this, we're going to get 3 minus square root of 3. That's going to cancel out. 1 minus the negative 1 is 2. So you get 2 divided by square root of 2. If you rationalize the denominator, you get a square root of 2 times square root of 2. And this is just going to be 2 square root of 2 divided by 2, which equals square root of 2. Excuse me. So basically what we have, this whole thing here equals square root of 2. And from what we just did, that's a good thing to practice because they're on tests and everything. And it goes a little faster when you get used to it a little bit. This one's a little harder because we had to adjust by multiplying the numerator and denominator by 2. All right, now let's finish this up. So basically, we have this to the 1/3 power. So basically, we have square root of 2, because we have to do this, to the power of 1/3. This is going to be 2 to the power of 1/2 to the power of 1/3, which gives you 2 to the power of 1/6. All right. Now, let's look at this 4a. So we're trying to solve for 4a. So you get 4 to the power of a. Well, this is just going to be 2 squared, and then to the power of a, which equals 2 to the power of 2a. Now, this equals 2 to the power of 1/6. Since my bases are the same, I'm just going to set 2a equal 1/6 and solve for a. So basically multiplying through by 1/2, this gives me a equals 1 divided by 12. And that is your value. Thank you. Have a nice day. Bye-bye.